Welcome to Prof.Ahilaa Max, Plus 2 Mathematics, Tamil Nadu State Board Syllabus, Chapter 1, Application of Matrices and Determinants, Video 1 is to 30, Exercise 1.5, First, Second, Third and Fourth Problems, Solving Systems of Linear Equations by Gaussian Elimination Method. Steps to Gaussian Elimination Method. This method can be applied even if the coefficient matrix is singular matrix and rectangular matrix. It is the method of substitution. Step 1. Transform the augmented matrix A bar B of the system of linear equations into row echelon form. Step 2. Do back substitution. Step 3. Get the solution. So what is back substitution? The method of going from the last equation to the first equation is called the method of back substitution. Understood? Very good. Exercise 1.5. First problem. Solve the following systems of linear equations by Gaussian elimination method. First subdivision. 2x minus 2y plus 3z equal to 2. X plus 2y minus z equal to 3. 3x minus y plus 2z equal to 1. Let us see the solution in Gaussian elimination method. First write the matrix form of the system, that is capital AX equal to B form. So collect the coefficients of the variables from the three equations. From the first equation, the first row comes as 2 minus 2, 3. So from the second equation, the coefficients are, see the second row, 1, 2, minus 1. And from the third equation, we get the coefficients as 3, minus 1, 2. And here the variable matrix is x, y, z. And the constant matrix is the right hand side constants 2, 3, 1. Now transforming the augmented matrix to echelon form, the augmented matrix A bar B equal to, first write the coefficient matrix A bar the constant matrix. Now we see this first element A 1 1. Usually we keep that as 1. So when we inspect the column, corresponding column, we see there is 1 occurring in the second row, first element. So it will be easy for us to make this first A11 as 1 by interchanging these two rows. So R1 interchange with R2, we get the first row as 1, 2, minus 1, 3. Second row as 2, minus 2, 3, 2. The third row remains the same. Now the A11 element is 1. Okay. We need to make the other elements A21, A31 and A32 as 0. That is to bring it in the row echelon form. Okay. Now see the A21 element, which is 2 here. We need to make it as 0 using the first row as our pivot row. The operation is R2 tends to R2 minus 2 R1. Similarly, A31 element is 3 here. To make it as 0, the operation is R3 tends to R3 minus 3 R1. So making those operations, we get the equivalent matrix like this. Next, I want to make this minus 7, that is A32 element to be 0. The operation is R3 tends to minus 6 R3 minus 7 R2. I use the second row as my pivot row. Okay. So the equivalent matrix is this one. Now I inspect that A32 element is also 0. And the other elements in the third row are divisible by minus 5. So to make simple, we can divide the third row by minus 5. Even without that, you can directly proceed to back substitution. Now I make R3 goes to R3 by minus 5. So that I am getting this equivalent matrix. Now converting to equations again and back substituting. From the third row, the equation is z equal to 4. Directly we are getting the value of z. Then from the second row, we get the equation as there is no x term, no? So minus 6y plus 5z equal to minus 4. Now substitute the value of z. So you are getting the value of y as 4. Now using the first row, the equation is x plus 2y minus z equal to 3. So that x equal to, substitute the values of y and z, we are getting it as minus 1. So our solution is x equal to minus 1, y equal to 4, z equal to 4. Good. Exercise 1.5. First problem, second subdivision. 2x plus 4y plus 6z equal to 22. 3x plus 8y plus 5z equal to 27. Minus x plus y plus 2z equal to 2. Let us solve. The matrix form of the system is capital AX equal to B. Collect the coefficient matrix, variable matrix and the constant matrix. Transforming the augmented matrix to echelon form. The augmented matrix A bar B is first A the coefficient matrix, B the constant matrix. Next we need to make it as row echelon form. Okay. So first I see A11 element which is 2 here. Also I inspect that the first row is completely divisible by 2. So if I divide this row by 2, I can make this A11 as 1. Okay. So the operation what I make is R1 tends to R1 by 2. Just divide the first row by 2. So equivalent matrix is the first row turns as 1, 2, 3, 11. Second and third row as it is. Okay. Now A11 is 1. Fine. Next we need to make the other elements A21, A31 and A32 as 0. Okay. Now to make A21 element which is 3 here to be 0, using the first row as our pivot row, the operation R2 tends to R2 minus 3 R1. Similarly, to make A31 element which is minus 1 here to be 0, just add with the first row. So R3 tends to R3 plus R1. This is the equivalent matrix what we are getting. Now I see the second row is completely divisible by 2. So for making simple values, I can divide this R2 by 2 completely. Okay. So I am getting this matrix. Next I want to make this A32 element which is 3 here to be 0 using the second row as our pivot row. So the operation is R3 tends to R3 minus 3 R2, getting the equivalent matrix like this. Converting to equations again and back substituting. From the third row, 11 is z equal to 22, so that is z equal to 2. From the second row, y minus 2 is z equal to minus 3. Substitute the value of z. So we are getting y equal to 1. From the first row, x plus 2y plus 3 is z equal to 11. Substituting the values of y and z, we are getting x as 3. Therefore, the solution is x equal to 3, y equal to 1 and z equal to 2. Exercise 1.5. Second problem. If ax square plus bx plus c is divided by x plus 3, x minus 5 and x minus 1, the remainders are 21, 61 and 9 respectively. Find a, b and c. Use Gaussian elimination method. Here the given polynomial is, let us consider that as p of x, that is ax square plus bx plus c. Now it is given when this p of x is divided by x plus 3, x minus 5 and x minus 1, we get the remainders as 21, 61 and 9 respectively. So let us recall the remainder theorem now. When a polynomial p of x is divided by x minus a, the remainder is p of a. So we get the following system of linear equations using this remainder theorem. See, when this p of x is divided by x plus 3, we are getting the remainder is 21. So our equation is p of minus 3 equal to 21. So substitute x equal to minus 3. We get the equation as 9a minus 3b plus c equal to 21. Next, by dividing by x minus 5, we get the remainder as 61. So the equation is p of 5 equal to 61. So substitute x equal to 5 here. So we are getting 25a plus 5b plus c equal to 61. Similarly, next, when we divide by x minus 1, we are getting the remainder as 9. So p of 1 equal to 9. So that the equation is a plus b plus c equal to 9. Now matrix form is capital Ax equal to b. Collect the coefficients and variable constants. We are getting the augmented matrix A bar B as A the coefficient matrix, bar B the constant matrix. Now I want to make this A11 as 1 because there is a 1 in the corresponding column. Okay, so it will be easy for me if we interchange these two rows to make this A11 as 1. So I interchange R1 and R3. So the operation is R1 interchange with R3. Understood? So A bar B is interchanging R1 and R3. We are getting this matrix. Next we try to make this A21 and A31 as zeros. So the operations are R2 tends to R2 minus 25 R1 using the first row as pivot row. Similarly, to make A31 as 0, R3 tends to R3 minus 9 R1. Doing these operations, we are getting this matrix. Now I see the second row and third row are completely divisible by 4. So to make it simple values, I make the operation R2 tends to minus R2 by 4 and R3 tends to minus R3 by 4. Okay. So this is the equivalent matrix. Now I need to make this A32 element which is 3 here to be 0 using the second row as my pivot row. The operation what I make is R3 tends to 5 R3 minus 3 R2. This is the equivalent matrix. Now converting to equations again and back substituting. From the third row, minus 8c equal to minus 48. So c equal to 6. From the second row, 5b plus 6c equal to 41. So b equal to 1 by substituting the value of c equal to 6 here. Okay. Similarly, from the first row, a plus b plus c equal to 9. Substitute the values of b and c to get the value of a, which is a equal to 2. Therefore, the solution is a equal to 2, b equal to 1 and c equal to 6. Understood? Very good. Exercise 1.5. Third problem, an amount of rupees 65,000 is invested in 3 bonds at the rates of 6%, 8% and 9% per annum respectively. The total annual income is rupees 4,800. The income from the third bond is rupees 600 more than that from the second bond. Determine the price of each bond. Use Gaussian elimination method. So here it is asked to determine the price of each bond. So let us consider that as our variables. Okay. So let the prices of 3 bonds be rupees X, Y and Z. Now it is given the total investment amount is rupees 65,000. So I get the equation as X plus Y plus Z equal to 65,000. Next it is given the rates of the bonds, that is 6%, 8% and 9% per annum, to get the annual income as rupees 4,800. From this I make the equation as 6% of X plus 8% of Y plus 9% of Z equal to 4,800. What is 6%? 6 by 100 into X. Similarly, plus 8 by 100 into y plus 9 by 100 into z equal to 4800. Now take LCM in the left hand side. We are getting 100 and cross multiplying we will be getting the equation as 6x plus 8y plus 9z equal to 4,80,000. Now the next hint given is the income from the third bond is rupees 600 more than that from the second bond. So how to convert this as equation? Income from the third bond. So it is 9 by 100 of Z. It is 600 more than that of the second bond. Okay. So I make the equation as 9 by 100 Z equal to 8 by 100 Y plus 600. Taking LCM and simplifying, the equation is 9Z minus 8Y equal to 60,000. So our equations are: first equation x plus y plus z equal to 65,000. Second equation 6x plus 8y plus 9z equal to 4,80,000. Third equation minus 8y plus 9z equal to 60,000. Now making use of these three equations, we try to bring the matrix form, that is capital AX equal to B. So consider the coefficient matrix, variable matrix and the constant matrix. Understood? Fine. Augmented matrix A bar B equal to, collect the A matrix bar the B matrix. Now A11 is 1 already. So I want to make A21, which is 6 here, to be 0. I make the operation as R2 tends to R2 minus 6 R1 using the first row as a pivot row. A31 is 0 already. So making this operation, we are getting this equivalent matrix. Next I need to convert this A32 element, which is minus 8 here, to be 0 using the operation R3 tends to R3 plus 4 R2 using second row as my pivot row. So this is the equivalent matrix. Now converting two equations again and back substituting. From the third row, we are getting 21 z equal to 4,20,000. So z equal to, dividing by 21, we are getting 20,000. Next from second row, 2y plus 3z equal to 90,000. Substitute the value of z. So we are getting the value of y as 15,000. Similarly, from the first row, x plus y plus z equal to 65,000. Substituting the values of y and z, we are getting x equal to 30,000. Therefore, the price of the three bonds are x equal to rupees 30,000, y equal to 50,000 rupees, z equal to 20,000 rupees. Got it? Very good. Exercise 1.5, fourth problem. A boy is walking along the path y equal to ax square plus bx plus c through the points minus 6, 8, minus 2, minus 12 and 3, 8. He wants to meet his friend at P of 7, 60. Will he meet his friend? The method mentioned here is Gaussian elimination method. Let us see. Here the path is given as y equal to ax square plus bx plus c. And it is given these 3 points lie on the path. Okay. So we know a point lie on the path means that point will satisfy that equation. So from minus 6, 8, we substitute x equal to minus 6 and y equal to 8. So the equation is 36a minus 6b plus c equal to 8. Similarly, from minus 2, minus 12, at this point minus 2, minus 12, substitute x equal to minus 2 and y equal to minus 12. The equation is 4a minus 2b plus c equal to minus 12. From the point 3, 8, at 3, 8, put x equal to 3, y equal to 8 in the equation. So we are getting 9a plus 3b plus c equal to 8. Now matrix form, capital AX equal to B. Collect the coefficient matrix, constant matrix, variable matrix, etc. and get the augmented matrix A bar B. Now simply I go for making this A21 and A31 to be 0 using the first row as my pivot row. See what operation I am making, that is R2 tends to 9R2 minus R1. Similarly, R3 tends to 4R3 minus R1. So our A bar B matrix is like this. Now I see the second row is completely divisible by minus 4 and the third row is divisible by 3. So I make the operation as R2 tends to R2 by minus 4, R3 tends to R3 by 3. So the equivalent matrix is this one. Next I try to convert this A32 element which is 6 here to be 0 using the second row as my pivot row. R3 tends to R3 minus 2 R2. This is my equivalent matrix. Converting to equation again and back substituting. From the third row, 5C equal to minus 50, so C equal to minus 10. From the second row, 3B minus 2C equal to 29. Substitute the value of C, we are getting B equal to 3. From the first row, 36A minus 6B plus C equal to 8. So here substitute the values of B and C, we are getting A equal to 1. Therefore, the path is y equal to ax square plus bx plus c. Here substitute the values of a and a, b, c. We are getting y equal to x square plus 3x minus 10. Understood? It is asked, will he meet his friend at p of 7, 60? Let us see. Here the path equation is y equal to x square plus 3x minus 10. So let this be the path. It is given minus 6, 8, minus 2, minus 12 and 3, 8 are the points lying on this path. Now his friend p of 7, 60 is here. If he wants to meet his friend means this point should lie in the path. Okay. Let us see. If the point 7, 60 lies on the path y equal to x square plus 3x minus 10, then he will meet his friend. That is, the point 7, 60 should satisfy the equation y equal to x square plus 3x minus 10. That means, if we substitute x equal to 7 in y equal to x square plus 3x minus 10, we should get y equal to 60. Let us check. Now put x equal to 7 in y equal to x square plus 3x minus 10. Substitute. Yeah, we are getting y equal to 60. Yes, therefore this p of s7, 60 lies on the path. So yes, he will meet his friend. Understood? Fine. Video 1:31 contents are 1.5 Applications of matrices, consistency of system of linear equations by rank method. Examples 1.29 and 1.30. Stay tuned. Success is ours. Thank you, my dear children.